Let's view an example illustrating Gauss Jordan elimination in action. Now, in this example, we have our original matrix given to us, as well as each of the 3 row operations that will need to be performed in order to achieve the reduced row echelon form, which leads us to the final solution of the problem. And you could see that I've left some blanks here for you to fill in. So, when we examine this initial matrix, we could see that the row 1, column 1 value is a 1, which is what it needs to be. So therefore, we need to change the rest of the entries in that column. There's only one other entry. We need to change this 2 into a 0. When you need to change an entry into a 0, you need to first ask yourself, what is the opposite of this value? The opposite of 2 is negative 2. So what I need to do is I need to multiply the row that has a 1 in the same column as the number that needs to change. I need to multiply this whole row by the opposite of the value that needs to change. So that's row 2. Once I multiply this whole row by row 2, and I'm going to write in these, I'm going to squeeze these values in right here, negative 2, negative 4, and negative 2. Then I will need to add these values to make my new row 2. So the row operation is the changing row is written first. So row 2 is the changing row. So you can see the row 1 values were just copied over here. So row 2 changes because we added to negative 2 times row 1. So negative 2 plus 2 is 0, which was my objective. I wanted to change that 2 into a 0, but you know that whatever I do to one side of the equation, I have to do to the other. So therefore, I need to continue on this process. Negative 4 plus 3 is negative 1, and negative 2 plus 1 is negative 3. So I've got my first column dealt with. I have my leading 1, and everything else in that column is zeros. So now I will move down the principal diagonal, and I see that there's a negative 1 in this position. However, I know that this value needs to be a positive 1. So to change a negative into a positive, all I have to do is multiply that row by negative 1. And you can see the row operation written here is negative row 2. That's the same as negative 1 times row 2. So that's a times row operation. Row 1 remains unchanged still. You see it's just copied over here. But row 2 values all change signs. So row 2 becomes 0, 1, 3. Now the last thing I can see is I've got my first column dealt with, got the next element on my principal diagonal changed to a 1. So all I have left to do is change this 2 to a 0. And what I told you before is when you need to change a number into a 0, take the opposite of that number and multiply it by the row that has a 1 in the same column. As the number that needs to change. I'm running out of room here as the changing number. Then add the product to the row that needs to change. So, row 1 minus 2 times row 2. Row 1 is the changing row because we always write the changing row first. So this is telling us that row 2 needs to be multiplied by negative 2. So negative 2 times row 2 values I'm going to squeeze in here. And then these are the two sets of values that I need to add up to get my new row 1 values, which are already filled in for your convenience, but you can see 1 plus 0 is 1. That shouldn't have changed. 2 minus 2 is 0. That was the objective that I needed to achieve. And 1 minus 6 is negative 5. So now I can write the solution to the system as negative 5 comma 3, or x equals negative 5 and y equals 3.